its simplest form, a differential equation is said to be a homogeneous differential equation if every term has the same degree. Homogeneous DE can be rewritten as m as a function of xy dx plus n as a function of xy dy is equals to 0. The m term here is what is actually indicated in the dx, and n what is actually indicated in the dy. There is a condition that if m is simpler, use x equals vy, dx is equals v dy plus y dv. And if n is simpler, use y is equals vx, and dy is equals to v dx plus x dv. Dx and dy here are just the derivative of x and y using product rule. To further understand the nature of homogeneous differential equation, we will have an example. So x minus 2y dx plus 2x plus y dy is equals to 0. This will be our m. This will be our n. We will let y is equals to v of x, dy is equals to v dx plus x dv. So we will substitute this v of x to our variable y. X minus 2 times v of x dx plus 2x plus v of x, and our dy, which is v dx plus x dv, is equals to 0. So we will substitute this dx to our inner term, which is x. This will become x dx minus 2 v of x dx plus, so we will use the FOIL method to simplify the two terms. So this will become 2 vx dx, 2x times x dv. This will become 2x squared dv. V of vx times v dx, that will become v squared x dx plus vx squared dv is equals to 0. And now we will combine like terms. This one will be cancelled and copy the remaining terms. X dx plus 2x squared dv plus v squared x dx plus vx squared dv is equals to 0. And we will simplify by dividing x both sides. This will become dx plus 2x dv plus v squared dx plus v x dv is equals to 0. This will become dx plus v squared dx plus 2x dv plus v of vx dv is equals to 0. So this will be 1 plus v squared dx plus x of 2 plus v dv is equals to 0. So we are now in the part where we can apply the variable separable. So this will become dx over x plus 2 plus v dv over 1 plus v squared equals to 0. And finally, we can now integrate dx. The integral of dx over x will be ln x, and this one we can separate this v squared dv plus the integral of v over 1 plus v squared dv is equals to 0. So copy ln x plus, and the integral of 2 over 1 plus v squared equals to arctan of v plus the integral of v over 1 plus v squared is 1/2 ln of 1 plus v squared is equals to c. So multiply both sides by 2 to get rid of this 2 over here. So this will become 2 ln x. 2 times 2 tan arctan of v is equals to 4 arctan of v plus ln 1 plus v squared is equals to c. And then the properties of natural logarithm, our 2 here will become the exponent of x plus ln of 1 plus v squared plus 4 arctan of v is equals to c. So the properties of natural logarithm, this addition form can be rewritten into multiplication form. So this will become ln x squared 1 plus v squared plus 4 arctan of v is equals to c. So we will now substitute the value of v, which is our previous value of y is equals to v of x. Our v will be equal to y over x. So ln x squared 1 plus y over x plus 4 of arctan of y over x is equals to c. So we will simplify this one. This will become ln x squared plus y squared over x squared plus 4 of arctan y over x is equals to c. This will become cancelled, and ln of x squared plus y squared plus 4 arctan of y over x is equals to c. So this is now our general solution and our final answer. So our next example is x cos squared y over x minus y dx plus x dy is equals to 0 when x is equals to 1 and y is equals to pi over 4. So this will be our m and our n. Since our n is simpler, then we will let y is equals to v of x dy is equals to v dx plus x dv. Substitute, this will become x cos squared of v of x over x minus v of x dx plus x times v dx plus x dv is equals to 0. So this will be x cos squared x, cancel, cos squared v minus v of x dx plus, substitute the x to the inner term, so this will become vx dx plus x squared dv is equals to 0. This will become x cos squared v dx minus vx dx plus vx dx plus x squared dv is equals to 0. Combine like terms, so this will be cancelled, and the remaining terms is x cos squared v dx plus x squared dv is equals to 0. Simplify by dividing both sides by x. So x cos squared v dx plus x dv is equals to 0. And proceed to variable separable. This will become dx over x plus dv over cos squared v equals to 0. And finally, we can now integrate. And the integral of dx over x is ln x plus, this is 1 over cos squared v is equivalent to sec squared v dv is equals to 0. Copy ln x, and the integral of sec squared v is equal to tan v is equals to c. And then substitute the value of v, which is v is equals to y over x. So ln x plus tan of y over x is equals to c. So this is supposed to be our general solution, but since we have here the a condition x equals to 1 and is equals to pi over 4, we will substitute these values to our equation. This will become ln times 1 plus tan of pi over 4 divided by 1 is equals to c. We will get the value of c since we're going to get the particular solution of this equation. This will become 0 plus tan of pi over 4 is equals to 1 and divided by 1, that will be 1, is equals to c. So our c here is equals to 1. And substitute the value of c to our general solution. So ln x plus tan of y over x is equals to 1. Is equals to 1. So tan of y over x is equals to 1 minus ln x. And we know that ln e is equals to 1. So we will change this 1 here into ln e. Tan of y over x is equals to ln e minus ln x. And the property of natural logarithm, that this subtraction form can be rewritten into the division form. So this is an ln e over x. So this is our final answer, the particular solution. So we are now in our third example. Y squared dx plus x squared plus 3xy plus 4y squared times dy equals 0 when x equals 2 and y equals 1. This will be our m and our n. Since our m is simpler, then we let x equals to v of y, dx equals to v dy plus y dv. Substitute the value of x, become y squared. Our dx is v dy plus y dv plus v squared y squared plus 3 of v y times y plus 4 y squared dy is equals to 0. So we will substitute this y squared to our inner term, which is y squared times v dy. So we have vy squared dy plus y cubed dv plus v squared y squared and dy. Let us substitute this to our inner term, dy plus 3v y squared dy plus 4y squared dy is equals to 0. So combine like terms, 3vy squared dy plus 3vy squared dy, this will become 4v y squared dy, and copy the remaining term. Plus 4y squared dy is equals to 0. Then simplify by dividing both sides by y squared. So this will become 4v dy plus y dv plus v squared dy plus 4vy is equals to 0. So this will become 4v dy plus v squared dy plus 4 dy plus y dv is equals to 0. So let us factor out dy. So this become 4v plus v squared plus 4 dy plus y dv. So we can now proceed to variable separable. This will become dy over y plus dv over 4v plus v squared plus 4 is equals to 0. And then we can finally integrate the terms. So the integral of dy over y is equals to ln y plus, so we can rewrite this into 1 over square of binomial, so this will become v plus 2 square dv is equals to 0. So we can let u is equals to v plus 2 and our du is equals to dv. So lny plus, so this will become du over u squared is equals to 0. So the integral of du over u squared, so u raised to the power of negative 2 plus 1 over negative 2 plus 1. So this will become u of raised to the power of negative 1 over negative 1. So copy plus, so that will become negative 1 over u, so this will become negative 1, and our u is equals to v plus 2 is equal to c. And then we will multiply both sides by v plus 2. This will become v plus 2 lny minus 1 is equals to c times v plus 2. So substitute the value of v, which is x over y plus 2 lny minus 1 is equals to c times x over y plus 2. So we will multiply both sides by y. So this will become x plus 2y times lny minus y is equals to c times x plus 2y. So this is now our general solution. Since we have here a given condition of x equals 2 and y equals 1, we will substitute these values to our equation. So let us substitute these values to our equation. X equals to 2 plus 2 and y equals to 1. Ln of 1 minus 1 is equals to c. X of 2 plus 2 of 1. So this will become 2 plus 2 times 1 is 4 times 0 minus 1 is equals to c times 4, or this will be equal to 4c. And then this will become 0. So the remaining is negative 1 is equals to 4c, and divide both sides by 4. So our c is equal to negative 1/4. So let us substitute the value of c to our general solution to get the particular solution. So x plus 2y lny minus y is equals to negative 1/4 times x plus 2y. Let us multiply both sides by 4. So this will become 4x plus 2y lny minus 4y is equals to negative x plus 2y. So x plus 2y lny is equals to negative x minus 4y is equals to negative x minus 2y. So 4x plus 2y times lny minus is equals to negative x minus 2y plus 4y, since we transpose this to the right side. So 4 times x plus 2y lny is equals to negative x plus 2y. So this is now our final answer, the particular solution. So this this is our last example. Y times 2x squared minus xy plus y squared dx minus x times 2xy x squared times 2x minus y dy is equals to 0 when x is equals to 1 and y equals to 1/2. So this is our m and our n. Since our n is simpler, we let y is equals to v of x dy is equals to v dx plus x dv. So let us substitute v of x times 2x squared minus x times v of x plus v of x squared dx minus x squared 2x minus v of x and our dy v dx plus x dv is equals to 0. I simplify v of x. This becomes 2x squared vx squared plus v squared x squared dx minus, this will become 2x cubed minus v x cubed times v dx plus x dv is equals to 0. So substitute this v of x to our inner term and d of x. So this will become v 2v x cubed and dx minus v squared x cubed dx plus v cubed x cubed dx minus, so using the FOIL method, 2x cubed times v dx, this will become 2v x cubed dx. 2x cubed times x dv, this will become 2x fourths dv, then minus v squared x cubed dx plus vx fourths dv is equals to 0. So 2vx cubed dx minus v squared x cubed dx plus v cubed x cubed dx. Then substitute this negative sign to our inner term, which is negative 2vx cubed dx minus 2x fourths dv plus v squared x cubed dx minus vx fourths dv is equals to 0. And then we'll combine like terms. This will become cancelled and this one. So the remaining term is v cubed x cubed dx minus 2x fourths dv minus vx fourths dv is equals to 0. Simplify by dividing both sides by x cubed. v cubed dx minus 2x dv minus vx dv is equals to 0. So this will become v cubed dx minus x, factor out, 2 minus v dv is equals to 0. And then proceed to variable separable. This will become dx over x minus 2 minus v dv all over v cubed is equals to 0. And then proceed to integration. So the integral of dx over x is ln x, and then we can rewrite this into plus v over v cubed dv minus integral of 2 over v cubed dv is equals to 0. Copy ln x, and the integral of v over v cubed is negative 1 over v plus, and the integral of 2 over v cubed, this will become positive 1 over v squared is equals to c. We will divide both sides, multiply both sides by v squared. So this will become v squared ln x minus v plus 1 is equals to c v squared. And then we will substitute the value of v, which is y over x. Y over x squared times ln x minus y over x plus 1 is equals to c times y squared over x squared. And then we will multiply both sides by x squared. This will become y squared ln x minus xy plus x squared is equals to cy squared. So this is now our general solution. For a given condition of x equals to 1 and y equals to negative 1, positive 1/2, we'll substitute these values to our general solution to get the particular solution. So this is our general solution. Let us substitute the given values of x and y. 1/2 squared ln times 1 minus 1 of 1/2 plus 1 squared is equals to c squared. So this will become 0 minus 1/2 plus 1 is equals to c of 1/4. So our value of c now is equals to 2. So let us substitute the value of c to our general solution, which is y squared ln x minus xy plus x squared is equals to 2y squared. So this is now our final answer.